Hello, welcome to GTC, the world's leading AI conference. My name is Konstantin Svetnov from Nvidia, and it's my pleasure to welcome Bo Hollis from Lockheed Martin. Today, we're going to do a deep dive of Lockheed's prepared software and present you with example configurations for how to deploy flight simulator environments from anywhere with Nvidia's RTX and virtual workstation technology. First, let us tell you a bit about who we are. I'm a solution architect here at Nvidia, and I've been with the company for about 5 years. I'm based in Atlanta, Georgia, and my focus is on the technical pre-sales of data center solutions for 3D visualization and artificial intelligence workloads, and my area of specialty is virtualization. Bo, why don't you go ahead and introduce yourself?
Hello, my name's Bo Hollis. I'm the software architect for the Prepared program at Lockheed Martin. I've been with the company for about 14 years now, and I've been on the Prepared team since it was first formed about 12 years ago. I'm responsible for steering our software architecture for the platform as a whole, but my area of expertise is in our DirectX 12 rendering engine, and I also support virtual mixed reality research that we do here at Lockheed Martin. I serve as a consultant for many of our customers, both internal and external, as they work to build training devices and services on top of our platform. I'm streaming to you today from our Innovation Demonstration Center in Orlando, Florida, where many of those training devices can be seen here on display.
Thank you, Bo. What a great setup you've got there. I can't wait to visit you at the Lockheed Innovation Center down in Orlando. So what do we have in store for you today? First, we're going to talk in detail about the Prepared platform, the architecture, the mission, and the ecosystem all working together to support the demands of the training community. After that, we're going to present you with example infrastructure designs and configurations for delivery of flight simulator experience on premises and in cloud environments. And of course, at the end, we're going to take some questions. All right, Bo, the stage is all yours.
Today, I'm going to talk about Lockheed Martin's approach to delivering flight simulator capabilities that meet a wide range of needs, from virtual reality to student laptops, desktop trainers, and even full dome simulators. While every solution has a unique set of requirements, many of the core common simulation and visualization capabilities are shared between them. And as a result of that, our approach is to package these common capabilities into a flexible software platform that we can use as the base for each new training device. This platform is called Prepared. It's a games-based visual simulation platform that has powerful content creation tools and an open software development kit. It's used extensively within Lockheed Martin to power a wide range of training devices and services, but it's also available commercially. In 2009, Lockheed Martin licensed the source code to Microsoft FLIGHTSIM 10, and that became the base for our new platform. Our primary goal for retaining its commerciality was to encourage an open ecosystem and continuously improve the platform based on customer and developer feedback. 12 years and 25 releases later, I'm really proud to say that's our primary goal, and I think we're executing on it quite well. Prepared is both an extensible platform and a fully featured standalone product. You can download Prepared from our website, install it, and start flying without modifying any settings if you want. It includes a full WGS-84 globe with 24,000 plus airports. There's landmark buildings, roads, rivers, lakes, parks, etc. It includes about 40 flyable aircraft models with 3D virtual cockpits, and there's also a large library of planes, boats, and vehicles which populate our virtual world with AI-driven traffic. Our built-in scenario tools can be used to place those models into a scenario and to apply customizable AI behaviors to them. Virtual and mixed reality support is also included in the core product, and we have integrations for SteamVR, Vario, VRG, and Oculus HMDs. Thanks to Prepared's open architecture, tools and interfaces can be used to access, extend, or even completely replace our core capabilities. Prepared supports joint distributed training via native multiplayer capabilities, or using standard network protocols such as DIS and SIGI to interoperate with other products. And that can be really important as you move up into higher fidelity training devices, because often the simulation work is just too demanding for a single computer to handle. For me, the real beauty of having an open architecture, though, is the platform's not limited by what we're able to create here at Lockheed Martin. There's a global ecosystem of developers that enhance Prepared with add-on content such as terrain, scenery, aircraft, sensors, rendering enhancements, VR headset integrations, and flight controls. SimDirector is Prepared's scenario creation tool. It has the typical entity placement and scripting capabilities you'd expect in a game-level editor, plus some specialized instructional capabilities for supporting use cases such as allowing a flight instructor to record and play back segments of their own flight, and then they could use that for demonstration purposes or even for grading against student flight segments. SimOperator takes the features of SimDirector and adds multiplayer support, which enables collaborative scenario editing, and it also allows a kind of a cool feature where the instructor can modify a scenario in real time while the students are running through it. The key to Prepared's open ecosystem is our software development kit, or SDK. The SDK can be downloaded for free from Prepared.com, and documentation for the SDK as well as for the Prepared application can be viewed online as well. SimConnect is a C++ API for high-level control of Prepared, and it has an option for a networked interface, which means that you could have your add-on running on a different machine. The Prepared Development Kit, or PDK, is a newer C++ API which provides lower-level access to Prepared's core features via modular services and interfaces. The PDK is what you need to use for implementing things like custom aerodynamics models, sensors, and hardware integrations. Many of Prepared's core capabilities are built using the PDK. Examples of this are our virtual reality and augmented reality capabilities, our air-to-ground radar, and our SIGI network interface. Developers can also extend the PDK with their own custom services as well. Our SDK download also includes tools for artists and scenery developers to create custom models, scenery, terrain, airports, etc. The SDK is essential to Prepared's success, not only because of the open ecosystem that it powers, but because it supports compartmentalization of sensitive data, which allows Prepared to remain a commercial off-the-shelf product, while still being able to support training use cases that may include classified or export-controlled information. Now I'd like to talk a bit about our rendering engine and just go a little deeper into how Prepared leverages modern GPU technology. In version 5, we decided to drop DirectX 11 support and go all in on DirectX 12 so that our new architecture could take full advantage of DX12 features like bindless textures and asynchronous compute. Thanks to DX12's improved threading support, we're able to add an extra rendering thread in version 5, and we've offloaded almost all of our DirectX calls onto background threads. That's had a really big impact on our performance, especially in how we're able to scale with multiple view and multiple GPU use cases. We also integrated with the Nvidia Aftermath SDK to help track down driver hangs and improve stability. Aftermath mini dumps can even be enabled in our retail builds, allowing customers, developers, and beta testers to provide better feedback in the event of a driver hang. Over the years, we've offloaded several aspects of our simulation to the GPU. This includes particle systems, weather and atmospherics, 3D water, and terrain mesh generation. Our water simulation is powered by Nvidia WaveWorks 2.0. We support single-pass VR and foveated rendering via variable rate shading. Finally, we support multi-monitor, multi-GPU, and multi-machine configurations. These are really important use cases for us, and our architecture is purpose-built to optimize for them. We rely on open research and industry best practices for our general approaches, but multiple views of multiple, full Earth scale scenes spanning multiple GPUs is not something that you're going to see in many commercial games. And so for that reason, that's one area that we've really been able to innovate. As I mentioned earlier, Prepared can be downloaded, installed, and used without modification. This makes it a great platform for doing research to determine what training use cases are best suited to leverage cloud technology. The biggest areas where I see cloud streaming being a challenge are meeting specific requirements around latency, image quality, and hardware support. That said, there are many use cases where these factors are less of a concern. For example, there are use cases where the vehicle is not moving at all, where the goal is vehicle-aircraft familiarization or procedural training. Something like a startup procedure, for example, could be scripted so that no interaction is even required for the student to kind of watch it progress through and use that as a study tool. They may also, fly in the simulator in the lab, and then when they get home, want to watch that scenario play back for after-action review, just to kind of go back through, see if there's something they could have done better. And doing that on a phone or a tablet via a streaming interface could be a great way to do it. And there could be some light interaction there to move the camera around to see things from a different angle. But again, the latency, the image quality, really not a concern there. And it's adding so much more value that, it'd really be worth it. For general aviation and navigational tasks, latency is probably less of an issue as well. In cases of things like satellite or drone operation, it may not be an issue at all because the real-world use case is already leveraging video streaming. Prepared has an academic license, and it's used in a number of schools and camps and places like the Orlando Science Center to introduce STEM concepts to kids through aviation. And this is really awesome for the kids. It's something I wish more kids had access to, and I think that cloud streaming could be a great way to provide that access. If you were looking to set up a persistent training environment where students can train together using multiplayer, cloud provisioning of servers and clients could be a good way to potentially scale that up to meet the needs of a large flight school. For content creator, a cloud server could be a great way to test and validate the content they're creating for Prepared. You've got 3D Studio Max, maybe Photoshop, those can be installed on that server, and you might have a terabyte of high resolution satellite imagery, different models and textures, and maybe a large model library that you're only using a few of them for your add-on. But having all that in one place, having it in the cloud on a powerful machine that can build out and export those models, and being able to access it from a lower end laptop or desktop, anywhere in the world, that could be a really powerful use case for that. Because Prepared can capture video, images, and telemetry data, I think it could be used well for building data models for machine learning, or doing different kind of applications of AI, or globe scale visualization, that kind of thing. So it's a powerful platform potentially for that because of the extensibility with the SDK and the ability to capture all that different data. Finally, I think virtual reality is a really interesting use case. It definitely has some added challenges because of the need for high resolution and low latency, but cloud streaming may be your best option if you need to view a scene in VR and you don't have access to the high-end hardware required. Nvidia's Cloud XR and Vario's Reality Cloud are a couple of examples of the exciting work that's being done in the industry to provide infrastructure for VR streaming. The applicability of VR streaming for flight simulators is an area that needs further research, but Prepared is a really great platform for doing that research because everything you need to fly around the world in VR is included with the core product.
Thank you, Bo. That was an excellent overview of Lockheed's approach to delivering flight simulator capabilities to the government and private industry. Now let's turn our attention to the Nvidia RTX and VGPU technology and how it can be used to accelerate those workloads on any device. The landscape of visual computing is ever-changing. We here at Nvidia are continuously seeing the growing demands of the market for increased resource requirements to accommodate larger model sizes, higher image fidelity, and scene complexity, as well as more flexibility in how visual applications are delivered. Centralized compute resources in the data center and cloud environments, for example, can vastly improve data security while allowing the streaming of user content and applications to a wide variety of devices like PCs, laptops, zero clients, tablets, and headsets. And let's not forget, COVID-19 has changed the way people work. More and more, the mission support staff, IT, and even trainees and trainers are geographically dispersed and working remotely. So it's massively important to have an IT strategy that covers all those scenarios. In addition, the development of AI technology and its integration into the application stack has boosted the demand for GPUs, which greatly accelerate machine learning training and inference. So how do we fulfill the demands of the visual simulation and training environments for graphics performance and scalability? The answer is Nvidia RTX. The RTX Enterprise driver, used in the Nvidia accelerated desktop and mobile workstations, is also available as an RTX virtual workstation licensed software. That enables customers to provide the same high-fidelity visual computing experience from the data center or the cloud. As we showcase the art of the possible in this presentation, we explore all of those scenarios: the RTX technology in physical workstations, RTX in on-prem data centers, and RTX in cloud service providers. So now let's take a closer look at the RTX stack. First, let's look at the hardware. There are two GPUs that we've designed for the highest demands of professional visualization and visual computing. And those are the Nvidia RTX A6000 and the Nvidia A40. The RTX A6000 you will most commonly find in a workstation or a PC configuration, desk-side workstation, local physical workstations, although it does support virtualization. The A40, on the other hand, you will most commonly find in a server scenario, a data center setup with virtualization, with VGPU, with a remote display or remoting protocol, and some type of a VDI solution. And they're both very similar in terms of specifications. They both have 48 gigabytes of GPU memory, which is scalable to 96 gigs with NVLink. Second generation RT cores for ray tracing, third generation tensor cores, and of course the Ampere architecture based latest CUDA cores. One of the few differences between those two cards is that the A6000 has 4 active display ports and the A40 has 3, which are actually disabled by default because, again, usually it's part of a server configuration. We are not using those display ports. You're actually using virtualization and remote visualization. So those two excellent cards we recommend for visual computing and, of course, for the training and simulation community because they are absolutely the best on the market when it comes to data center graphics and workstation graphics. Now, let's take a closer look at the RTX data center stack, including the hardware and software components. We already spoke about the Nvidia A40 card, which ships as part of a server configuration. Many servers allow multiple cards per node to maximize performance and user density. Work with your OEM and Nvidia account team to identify the correct platform. A hypervisor will then be installed on the server to host the virtual desktops. Nvidia supports various hypervisors like VMware ESXi, Citrix Hypervisor, previously known as XenServer, and RHEL KVM. The most commonly deployed hypervisor, though, in my observation, continues to be VMware ESXi. You will then deploy the VGPU software to enable GPU virtualization, which makes it possible to share physical GPUs across multiple VMs. The VGPU software, which we used to call Grid, was launched almost a decade ago and is being used by customers around the globe to deliver high-performance VDI environments for 3D visualization, office productivity, and compute-intensive applications. The software edition of VGPU that unlocks advanced graphics rendering capabilities and is widely supported and certified by major application providers is called the RTX Virtual Workstation. Because VGPU is a licensed solution, it comes with enterprise support directly from Nvidia, which is critically important as you move your simulation environment to production. In the previous slide, we talked about GPU virtualization, and we kind of alluded to the concept of GPU sharing, right? Or having multiple virtual machines being attached to the same physical GPU and concurrently using those GPU resources. So let's take a look at how that's actually made possible. And we have a concept in the VGPU realm called profiles. And so let's assume for a moment that you are using VMware vSphere as a hypervisor and obviously using vCenter as your management tool, which of course is a requirement when it comes to VMware. And so what you would do there is when you create one or more virtual machine, you're going to have an option to add a new PCI device into the settings of that virtual machine in vCenter. Okay, and that virtual PCI device will then present you with a number of options for a vGPU profile. Now that's assuming that you've already installed the driver on the hypervisor itself, which comes in a VIP package, and I'm gonna show that in a second here. But assuming that you've done that part, now you're gonna be presented with all these different options for profiles when you add a virtual PCI device to the virtual machine settings. And so let's take a look at what that profile actually means. The profile actually defines how much graphics memory, or GPU frame buffer as we like to call it, you're giving to the virtual machine, and also what license edition of the VGPU software you're going to be enabling or activating within that VM. And that's of course dictated by the license edition of the license edition that you've purchased from Nvidia, or the evaluation license that you got via our trial program. So when you select an A40-8Q profile or a grid_A40-8Q profile, what that means is that you're taking an A40 card inside of your server, and then you're allocating 8 GB of GPU memory to that specific virtual machine. And then you're also activating the Q license. Q stands for Quadro, which is kind of the predecessor of RTX, more or less. And that means you're enabling the RTX virtual workstation license and the entire capability of the card for 3D visual computing and advanced rendering applications, as well as a multitude of display configurations, endpoint configurations, monitors, resolutions, etc. Right? So the Q profile, which is the virtual workstation profile, really unlocks the entire graphics processing capability of that GPU, and that's what that profile and those labels inside that profile actually stand for. So if I wanted to, let's say, increase the graphics memory allocation for that particular virtual machine from 8 GB to 16, I would shut down the VM, I would go into the edit settings in vCenter, and then I would select a different profile. Let's say I would go with 16Q instead of 8Q. So now I'm providing 16 GB of exclusively assigned graphics memory to that GPU. And of course, the A40 has 48 gigs of GPU memory, so you can go as low as 1Q, right, as low as a 1 GB profile, all the way up to 48 GB of graphics memory, and it's all going to be dictated by the requirements of your application, which is why it's very important to test whenever you're doing a proof of concept or you're deploying a pilot environment. You should test your workload, you should capture the resource utilization, and that's going to help you right size the environment and maximize and scale and maximize your investment. So what are the steps to deploy the virtual GPU software? Well, the first thing you're going to do is you're going to download the VGPU software from your Nvidia Enterprise portal. And the software is going to come in a bundle. You're going to see a single bundle which is going to contain the drivers for your specific hypervisor of choice. So if you are running, for example, vSphere, then you're going to want to download the latest VGPU, let's say, VGPU version 14 for ESXi version 7.0, for example, or 6.7 in some cases if you're running older version of ESXi. And you're also going to want to go ahead and download the NVIDIA license server appliance. Now, previously we had another license server platform which was based on Flexera, which is still available in the portal, but frankly, I would recommend going with the new in-house developed NVIDIA in-house developed license server called NLS. And we have both an on-prem option called Delegated License Service, DLS, or we also have a cloud option called CLS, which allows you to connect all of your virtual machines to an NVIDIA managed cloud license server, so you can offload the management of your licensing infrastructure to NVIDIA if you would like to do that. But ultimately, you're going to want to have, so you're going to sign up to that portal. Once you purchase your entitlement, you're going to have instructions from NVIDIA on how to do that. Or if you are doing a trial, you're going to fill out a form for evaluation, and you're going to get an email from NVIDIA with instructions to sign up to the enterprise portal. And then from there, you'll be able to download the software. So then next, you're going to, of course, have to deploy that license server that we talked about. And fortunately, with our new licensed server platform for on-prem with DLS, we do have an appliance option. So you can import a virtual appliance into vCenter and do your deployment that way. And it's very, very easy. Or if you are going to choose the cloud option, then obviously skip that part. There are some additional configurations that are part of our documentation that I advise you to read on how to connect your clients, how to bind your entitlement and all of that. So I'm not going to go too much in detail on that because it's all documented, but just keep in mind that if you're going to go all on-prem with no external access, then obviously you're going to want to use DLS and the virtual appliance. And then you're going to want to install the VGPU hypervisor driver, which in the case of ESX comes in a standard VIB installation package. So you're going to mount that or you're going to drop that VIB onto your ESX file system, and then you're going to install it as it's documented very, very well in our product documentation. And then you're going to reboot the host. One way to verify the VIB installation, and frankly the best way, is using Nvidia-SMI. So you can SSH into your ESXi host, run Nvidia SMI, and get the correct output, which is the correct version of the driver, as well as it'll show you a whole bunch of other information about what GPUs you're using, what are some of the configuration parameters and thermal settings on the GPU, and a lot of really useful information with Nvidia SMI. If Nvidia SMI fails or returns an error, then that points to a potential problem with the installation. Something didn't go the way it should, or there is additional settings within vCenter or even BIOS settings that are very well documented, typically by your OEM. And then, as we said before, in order to get access to the profiles, right, you're going to want to go into your VM settings in vCenter for the specific VM you created, and you're going to want to add that virtual PCI device and choose a profile that fits the application requirement. And then you're going to create a VGPU, and then you're going to actually boot the virtual machine you created to be obviously your virtual desktop in this case, that you attach the profile to, and you're going to go through the installation of the guest driver. And the guest driver, in the case of Windows, it's going to be just a straight executable, right? We have an executable for Windows 10, also for Windows Server. Or if it's a Linux OS, then like Ubuntu or RHEL, then there's also a .run file that's provided as part of that driver bundle. And so you're going to run that in the VM as it's described in our documentation. Then there's a few extra steps to configure your VMs to essentially talk to your license server or connect to your license server and actually grab a license. So I'm not going to go in depth on that, but just remember that it's not just magically going to work once you have the VM created and the driver installed. You actually do have to go and tell it how to find the license server, and most likely that's going to require a reboot. And then from that point on, you're done. You can do one of two things. You can do some benchmarking with some of the more synthetic benchmarks that are available out there on the internet for free, and kind of figure out how your environment's working, what frames per second you're getting, right? Whether your VGPU profile is actually working within certain applications, or you can go straight to installing your actual real-world applications and workloads, and then start doing testing and start capturing that data to see if you've right-sized your environment, or you need to go a step up and increase your profile, or you could potentially get away with a lower profile so that you can fit more virtual machines onto the same GPU. Remember, there's always a trade-off, right? The larger the profile on that virtual machine, the less VMs you're going to have on a GPU, and vice versa. The lower the profile that you're using on a VM, the more VMs you can accommodate on the same GPU. So it's very important to test your actual applications with actual users who are, willing to be your beta testers, and then go from there. And a prime example of an excellent tool to use during your testing when we talk about right sizing and when we talk about capturing resource utilization is the GPU profiler that you can find on gpuprofiler.com or on the GitHub repository, where one of our solution architects called Jeremy May develops and maintains this profiler tool. And I personally use it all the time in my POCs because I can drop it on a physical workstation that has Nvidia GPU, or I can put it on a virtual desktop, virtual machine that has a vGPU, and I can capture CPU and RAM utilization, but I can also capture GPU frame buffer, which is very important for your profile. Remember, if you have let's say an 8Q or 8 GB profile, and you see that blue line there kind of, moving up to closer to 100%, that's probably a good indication that you may need a larger profile. Or if, for example, it's staying, somewhere underneath 50 or 40 or 20, that might be a good indication that you can get away with a lower profile, so you can put more virtual machines on that particular GPU on that server. So excellent tool, highly recommended. Totally free, very easy to use, and very easy to capture data because it provides you that visualization to be able to analyze what's going on in real time or capture it and analyze it offline. So now that we've shown you the power of GPU virtualization and how to install, configure, and deploy a vGPU environment, let's take a look at the actual deployment scenario and performance optimizations for Lockheed's prepared software. We did some testing in-house, and we came up with some example configurations that you may choose to start with when designing your FLIGHTSIM environment. Now, one caveat here to be aware of is that you shouldn't treat these as official recommendations from either Nvidia or Lockheed. These are just example configs that we as engineers have used in our testing to show the art of the possible. So go ahead and give them a try. There are 3 scenarios that we wanted to explore: an on-prem server with virtualization, a cloud service provider instance, and a local RTX workstation. In the on-prem server scenario, we had a Supermicro box with one Nvidia A40 card, which we virtualized with VMware ESXi and an 8Q vGPU profile. In the CSP scenario, we deployed an instance on Microsoft Azure, which uses an entire GPU on the backend since GPU partitioning is not available just yet. This particular instance runs on a T4. And lastly, the third scenario is an instance of prepared software running on my local Razer Blade mobile workstation, which has an RTX 5000 card. We wanted to make sure we captured the baseline performance of how the game would run locally compared to the remote scenarios. Okay, let's take a look at how my physical RTX laptop performed. Flying this beautiful airplane was a very smooth experience. I could turn various features within Prepared on and off and increase the level of detail and image accuracy, and I could still get 30 frames per second consistently and easily. This makes sense because we're not moving pixels over a network, and with the compute resources being local, the inherent latency is kept to a minimum. And although my CPU and GPU cycles could spike up pretty high at times, my GPU frame buffer utilization also stayed consistently under 50%, which on an RTX 5000 card means I didn't exceed 8 GB of GPU memory at any point. This is a good starting point when you design a virtualized or remote streaming environment, and it leads us back to that 8Q profile we talked about before. Now, let's take a look at the remote scenarios. The on-prem data center and public cloud deployments produce similar outcomes. As you can see by the movement of the light blue line in the GPU profiler, the application never really exceeded 50% of GPU frame buffer, which on a 16 gig T4 card is, you guessed it, 8 GB. We were able to achieve up to 30 frames per second while flying on that VM instance, although since we are using a remoting protocol, the true remoted FPS may be different or slightly lower. In the case of Azure, we use the Teradici PC over IP client, which is very easy to install and doesn't require complex broker infrastructure. In the on-prem VGPU scenario, though, where you can build a full-blown VDI environment, the VMware Blast Extreme protocol is also an excellent choice to stream the FLIGHTSIM application. Both protocols allow me to pass through my USB yoke system just fine, and the input controls reacted quite well without a very noticeable delay on the VM, although that's where your network latency may start to become a challenge. Now let me turn it over to Bo to go a bit deeper on some of the features and optimizations within Prepar3D that can help increase the visual quality and that can be quite useful in those remote scenarios.
I'm going to talk a little bit about what's going on under the hood here to make some more sense out of these numbers. So the first thing that might jump out at you is the 30 frames per second and maybe kind of the low GPU utilization here. Reason for that is in our graphics settings, we have a frame rate limiter and we just set the default to 30 frames per second to hit a broad range of hardware and provide a smooth experience for customers out of the box. That's completely configurable. It goes up to 120. It also can be disabled entirely. But if you are streaming video, you might want to use that frame rate limiter, set it at something near or a little bit above the frame rate of the video that you're planning on streaming out. And that way our job scheduler can use any remaining frame time to do some extra work and keep things running smoothly. So looking at the CPU utilization, it looks low, but then if you look over there, the main core thread here is running 100%. And that's almost always the case regardless of your settings. Maybe with VSync, it might not be if there's a thread that's blocked, but using the frame rate limiter, we'll be able to use that extra time to do work. So you will see that main thread almost 100%. Now then, the next two threads there are probably our rendering threads. And those are doing per frame work, but they will spend a little bit of time waiting for the next frame to begin once they're done. So they probably won't be at 100% unless you have things like super balanced. And then the rest of the threads are asynchronous job tasks. You can see one of the job queues is a little bit more full than the others. We do have jobs that kind of happen pretty frequently every frame for things like instancing or batching of models, but where you'll really see those light up is if you start flying fast or go into slew mode and moving the camera rapidly. When the terrain's paging in, you'll see that those terrain jobs are creating new textures. We're paging in scenery models at the larger draw distances and density settings. That can be a lot of work, and that's why we leave background cores kind of open and available for that asynchronous job. And so that's something to think about if you're configuring your cloud instance. You're going to want at least 4 cores. I would recommend probably 6. And you can kind of see why there with the default settings. 4 of them are being pretty utilized, and you want to have a little bit of extra headroom there for when the terrain is paging in. As you just saw, things are running really well there on default settings. But to really get the most out of the hardware and software, you're going to want to tune your settings to optimize for your specific use case. Prepar3D has a ton of configuration options in our user interface, as well as more in the Prepar3D config and other config files. These are documented online, but I wanted to quickly go over a few that could be useful for cloud scenarios in particular. So settings for things like terrain, texture, and mesh resolution, draw distance of different object types, scenery density, and traffic density are going to impact you more on the CPU utilization side of things because there's more objects to process or there's higher resolution data to stream in. Settings like volumetric clouds, shadows, and anti-aliasing quality and reflections and lighting, those are going to impact you more on the GPU side of things and also impact how much VRAM is required. And that's something you're going to want to keep an eye on because Prepar3D does not allow VRAM to be overcommitted for performance reasons. Prepar3D's official minimum requirement here is 4 gigabytes of VRAM, but we do have some users who are able to tune their settings and content down to get their usage under 2 gigabytes. So that's something you might want to keep in mind if you are trying to set up a lab or something with multiple seats. You're trying to optimize for getting as many seats as possible out of a GPU or out of a server, then lowering settings might be a way to get your budget down and get the performance in an acceptable envelope for each seat to get more boxes going. We display the VRAM usage on our InfoGen text right next to the frame rate counter. So what you probably would want to do is turn the frame rate limiter off and then change some settings, go back into the sim, kind of pop in and out of the settings, look at how that's impacting the frame rate and also the VRAM usage. And then you could turn that frame rate limiter back on. And like I mentioned before, set that so that Prepar3D is running at a similar speed to your streaming video. And that'll leave our job scheduler some time in the frame to do extra work and keep things running smoothly. So speaking of the job scheduler, we do have some advanced settings in the Prepar config, which allow you to adjust the affinity mask, not just of the prepared application, but also in v5.3, we added a new thing called the prepared core affinity mask, and this is a mask that applies just to our job scheduler threads. And so these are the prepared like main thread, the two rendering threads, and those asynchronous job threads for things like terrain loading. So where this would be really useful is in the application space, that also applies to DLLs that are linked with the executable. So if you're creating an add-on DLL that's doing something like eye tracking, you may need to spin off your own thread to be polling a sensor at a high frequency. And you would want to make sure that thread is not going to be contending with Prepared's main thread and maybe causing like a long frame or a stutter. So that's kind of what that mask is there for, is special cases like that. The other thing you could do is if, for whatever reason, there's another application in the OS that's running and it's on the same core as Prepared's main thread and there's contention there's preemption that's causing like a long frame or a stutter to happen, instead of having to mask that whole core off to alleviate that stutter problem, you can actually reassign the location of Prepared's main thread to a different core. And then, so core 0, instead of being the main thread, will now just be a background thread for terrain loading. And if it gets preempted by whatever other task is running, it won't be a big deal because, that job just takes a little bit longer to finish. So finally, I'm going to talk about our command line switches. So if you don't want the end user to have to go through and click through the user interface to select their aircraft and select their scenario, or in multiplayer in particular, you can select a role and select a server to connect to, etc. So if you want to have all that pre-configured, you can actually use the command line switches to jump into a scenario, jump into multiplayer, jump into our tools, sim director and sim operator. And then finally, there's a command line switch for a headless mode, which would be really useful if you're trying to provision a multiplayer server in the cloud. Because this headless mode basically turns off the rendering. We're still doing enough of the work to run animations so that things like attached explosions or whatever, those effects will kind of still be run through far enough so that the server is sending out all the right information. But we're not going to be drawing anything to the screen. So if you were to log into that machine and look, you'll see a black screen for the output. That's going to drastically reduce your GPU requirements for that system in terms of VRAM and all that. So that's a good one to think about if you're looking at setting up a multiplayer scenario in the cloud.
Thank you, Bo. And this concludes our session. Now, we're going to stick around for a few more minutes to take your questions.
If you do want to learn more about Prepared, we do have a public website with the product overview and the SDK documentation available online. The SDK download is free, as is access to our forums. And the developer team and myself are active there on the forums, answering questions and just engaging with our third-party developers and our customers. So that's really the best place to go if you've got questions about, how to get up and running or how to optimize your use case, etc.